That segues really well into something else that I wanted to make sure to talk to you about. And we can get as deep into it as you want because it might tiptoe into a little bit of proprietary stuff. But can you speak a little bit to how a lot of cannabis extracts are produced? What are some of the technologies and processes involved? How do they differ? What are the pros and cons? And what, specifically in your context, what do you prefer and which ones are you a little more kind of skeptical about, that sort of thing?
So this is the casual extract question for all extract or processing companies.
Yeah.
They split themselves up into about a few different categories. Solventless, concentrate or extract is your first category. So I really focus on what's an extract, what's the botanical term for extraction.
Right.
So using a solvent to remove undesirables and to preserve desirables.
Yeah.
I mean, using a solvent, people laugh about, is water a solvent in cannabis? Water is a solvent for water-soluble
Exactly,
things.
yeah, things that are more polar.
So, sure. So in this context, the body of the trichome is the resin. It's nonpolar, so we use nonpolar solvents. Something solventless would be mechanical, or steam or pressure, like rosin or hash or sift, and that preserves the complete resin profile, but with impurities.
Right.
So it's not an extract. And then, so what's a solvent? It could be butane or CO2 or alcohol. What are you trying to extract, and what are you trying to prevent from co-extraction?
Right.
So alcohol has some polar qualities to it. It's going to pull other portions of the resin. There's something is not black or white, polar or non-polar.
Right.
It bends how it wants to bend, but mostly in there it's non-polar. There are some water-soluble portions of molecules.
Exactly.
So it's actually, and then you have butane. So I find butane is this miracle of God molecule, and it actually gets more polar as colder it gets. So you can actually bend it to grab a little bit more of that
You can get more
water
selective.
and where that water solubility in nonpolar is, where flavor is, sort of. It's the flavors of things are in the esters. And so butane is just a great buffer as well. So when we talk about science and biology, the first thing we do is talk about charge and buffers and how to prepare solutions for extraction. And so when I come up to this problem in cannabis, when I got done with academia and government and everything, it's a problem right in front of me. It's a separation problem that needs buffers. And so certain things work better than others. You have CO2. So CO2 doesn't have a hydrocarbon equivalent, although it comes from the industrial gas complex. Impurities could be added to CO2 just like
any
hydrocarbon, right? And so, but you have to bend CO2 in a few different directions. You say, I want a heavier molecule, I want a lighter molecule. In the end, I'll put them back together.
Yeah.
And so Humpty Dumpty got put back together again. It never, as I extract biology in my life and my career, I could not reassemble complexity in the reverse direction. To any meaningful extent.
Yeah, I mean, that's a common issue in herbalism. I mean, going back to old roots of alchemy, that's, and I don't want to deviate too much because we'll get to this, but this ties into the concept of full spectrum and everything. And this concept that a lot of herbalists have been chasing down for a long time is how do you capture the plant essence in basically a liquid form, essentially. And the most common way is taking all different parts of a plant, extracting it, trying to mix it back together. But to your point, when you do that and you mix things back together, you tend to find that things have changed, regardless of the ways you've tried to control them.
Yeah, cannabis presents the most complicated example of all this. If you want to extract salicylic acid from willow bark, I mean, it's right in front of you. You just remove everything and you get the one water-soluble compound. And it brings down your inflammation, it takes your headache away. But when you're talking about cannabis, it's incredibly complex, and oxygen and everything affects what's happening there.
Especially with terpenes that are very, very sensitive to oxidation. And
so, you know, and then you say, how do we, what is full spectrum? And it's kind of like, it changes. Don't let anyone tell you that we have different standards for what full spectrum is. I don't smoke the cannabis plant to get chlorophyll.
Right, right.
So I usually put that quote on your Instagram, and he says, we all have different standards. We don't have. We use cannabis for one reason, the resin of the trichome, right? And so we want that complete resin. You toss everything else out. I'll get my chlorophyll from somewhere else. I'll get my antioxidants from somewhere else. I'll get my proteins and my starch. I don't need this stuff from cannabis. I want a bioavailable cannabis product that I can use in an administrated way, which is a vapor that works best for my chemistry and evolution species, right? So full spectrum is different for each batch of cannabis that you collect. And so and you want to carry the complexity throughout the extraction, but make it available. And so what I find throughout all my extraction and scientific knowledge is I've seen things come together and never be able to come apart again based on the chemistry you're using. And I feel a lot of that is happening in cannabis concentrates today. They polymerize with substances on the exterior of the leaf and what's trying to be protected on the interior of a trichome, lock it in place. And then when you go to vaporize it, almost like boiling water with salt in it, you're just getting these strands of glops coming flying at you. And the THC works just the same. You say like this to the product, it works, but you want all those things individual. So when they vaporize, you want them all individual, and so you can each once your sensors and everything can get in there, and they can all get into your alveoli and in your bloodstream as individual molecules. And so what is full spectrum? It's taking that complexity of each batch and making the entirety of it available.
And maintaining, and when you're saying maintaining the complexity, you mean maintaining the complexity of those resins?
Yes, the resin that's in the trichome of the batch of cannabis. So when we come to hemp, so in cannabis, we've had this structure where you got Girl Scout cookies, and you grow a whole room of it, and I extract it, and it's pretty linear. I mean, I could test a nug and the terpenes, but it's pretty linear. Now I walk out into the hemp field, and I have Jack Air, Grape Crush, Trainwreck. It's just all over the place. And they're going to try to make some product, a combination of oils, and it's just going to be like wedging a whole bunch of flavor and experience, just ramming it all together, even if it's not bioavailable, which in 95% it won't be. It's just not going to be what we know of cannabis, which is individual selections.
And even just talking about the flavor bit, I mean, that's easy to illustrate just thinking about foods. Like, you don't want to take a bunch of different flavors of, I don't know, cakes or candies or something and merge them all together. That merged together flavor is not going to be as good as tasting each individual unique flavor.
Thanks for bringing up the food thing, because it's great. So another person's extract or technology is like an egg, flour, water, and oil mixed up and set in front of you and say, this is your cake. And so, you know, what we're trying to do is add a little bit of baking soda and put it in the oven and, you know, understand what about the natural chemistry. When the first person made bread, like what did they understand about how the proteins in it had sulfur and made it connect together and made the dough elastic and made it rise? It was special about the chemistry of that. But you'd never know that if you didn't go through the correct sequence. So I think with a lot of cannabis extracts, it's like an unbaked cake.
Yeah, it's almost like
it has all the parts, but it's not.
It's like getting the box cakes. You know, like it seems like a lot of folks are jumping into starting labs. They're getting the equipment that they know is the basic equipment to doing basic processes, and they're making a cake technically. You know, out of the core components. But it's nothing like if you went to a bakery and bought a cake from someone that really understands, you know, the complexities to draw out flavors, make things rich and enticing, you know, all these different things.
Yeah, so it's just that little bit of extra, and it is found in chemistry and understanding.
Yeah.
And so there is proprietary parts of it. So we're working a lot with the combination of CO2 and butane. And so it's not rocket science, and everybody does it actually, but we're scientists, so we just sequence it correctly. And what we found is that CO2 is the perfect co-solvent, is the term we're using. So what it does is it gets into the resin, and all the parts that would polymerize or attach or oxygen would affect the resin, we charge it with a CO2, like you would carbonate a beverage. And then we run the extraction, and with our sequence, we understand that the CO2 keeps it together, and it eschews like the butane and the solvent, and keeps its terpenes and all its complexity folded together. And then when we relax it and let it release, it unfolds and burps and effervesces, and all those CO2 kind of come off all those oxygens and those double bonded areas, and then you can really start to taste all those molecules start to kind of unravel. So in a sense, we protected all the molecules during the extraction. And at the end, there's no wax for them to lock together and to polymerize, and now you're able to pick it up and dab it, and the vapor, you're able to taste kind of each one. And we would hope each one would get into the bloodstream individually and have all the effects it's supposed to have.